Okay, fantastic. And we'll hit that one in just a second. What can you tell me about parentheses? Did anybody come up with an inaccuracy about parentheses? What'd you think of?
If there's a parentheses inside of the parentheses, you have to do the one that's inside of the other parentheses.
That is very true. That is an actual statement about parentheses. You're right. I wouldn't necessarily call it an inaccuracy. It just doesn't go far enough to explain that. But there is something about parentheses. Parentheses are not always parentheses. When is a parentheses not a parentheses? Say it. Go ahead. When it's a multiplication. Yes, when you write 2 parentheses 3, that's not a parentheses. It is, but it's not a parentheses in the sense of our first step in order of operations. That is a multiplication symbol. What would probably be a better way of stating this would be to call parentheses grouping symbols, right? Write that down because that's a better way to think of it as grouping symbols. So yes, naturally there are parentheses. What other grouping symbols exist that fit into this category still? You know, tell me one. Another grouping symbol that you use. Brackets, yes, the brackets with the square top and bottom, you know those. Whenever, like you just mentioned, somebody just mentioned, when you have Blaine said, when you have a parentheses within a parentheses, you make the outer one brackets. That's exactly right. There's another one. It's not the squigglies. That's set notation. And those aren't actually used in an operation. They're not actually used in an equation. They're used to show a set, like a solution set or a replacement set or some type of a set of numbers. So no, those are not actually grouping symbols in terms of operations. Who said it? Yes, that was exactly what I was looking for. That's the one. These right here, top to bottom straight lines, absolute value. I'm abbreviating there. Yes, that's your grouping symbol. So those are ones that need to be dealt with first. Whatever's going on inside of grouping symbols, you need to get rid of those. Take it down until there's no more grouping symbols. Second is exponents. You knew that. What does it mean when it says do exponents after parentheses? What are you doing to exponents? Can you use a mathy word and tell me what are you doing to them? You're evaluating them. In other words, if you have a 4 to the 3rd power, when it says to do the exponent, you need to rewrite that 4 to the 3rd power as a whole number. Yes, exactly right. Do you know what whole number? 4 times 4 is 16 times 4 is somebody. That's what calculators are for, huh? 64. I heard somebody say it. Yes, that would become a 64. That's what that means. Good. Okay, then Laurel was talking about multiply and divide here, and she mentioned how it's not multiply and divide. That is absolutely one of the inaccuracies I expected you to write down. It's not always multiply and then divide. It's multiply or divide from left to right. Those are equal value, okay? So in order, left to right. Just jot that down. And same thing with add and subtract. In order, left to right. Altogether, those are your order of operations. Boy, it sounds simple when you say it like that, doesn't it? It's not quite so simple when you actually apply it, is it? It gets a whole lot more complicated when you actually try to solve in evaluating expressions. So I've used that word evaluate twice. That's an important one. What do I mean when I say to evaluate? What is that word telling you to do? Say it again. It means technically, and I'm going to put these in quotation marks, it means to solve the problem or answer the problem. I'm putting that in quotes because actually you don't solve an algebraic expression. You only solve when there is an equal involved. Solving an equation, and you know this from algebra, solving means taking it all the way down until you have a variable alone on one side and a number alone on the other side to equal, right? That's solving. X equals 10. That's solving. If there's no equal sign, you're not actually solving, you're just simplifying. That's what it means to evaluate, to take a big expression and simplify, 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 simplify until it's as simple as it can get. All right, so another good word for evaluate is simplify. Those two words are synonymous. They mean the same thing, evaluate and simplify. Okay, do I need to define variable? We got this? You know what a variable is? What's a variable?
Something that stands in for a number.
Yes, we use letters, but it doesn't have to be a letter. Could I do all of algebra using nothing but ice cream cones and smiley faces and little rainbows if I wanted to? Yes, because all it is a symbol that represents an unknown number. You with me? So you don't have to use a particular letter. We use them just because we're all familiar with them, right? We all have a name for them and we know what to call it. But we could just as easily say smiley face equals 10 and use a smiley face symbol to stand in for it. You understand what I'm saying? Nod at me a little bit if you're with me. Okay. So that's an important word. An algebraic expression is one that has no equal sign. Those are what we're talking about today. No equal sign. That would make it an equation. And then a term. I'm going to use the word term a lot. You're going to hear me say that. A term could be a number or a variable or the product of a number and variable. For example, just some examples of a term. 10a is a term, right? X to the third, that's a term. Negative 15/17 a to the third b squared c, that's a single term. All right, but x plus 4 is not a term. That one is not a single term. That one is two terms. It's a binomial like we talked about yesterday. Follow what I'm saying? So when I say a term, I'm talking about either a variable or a number or the product of a number and variables. Okay, I think we got the boring stuff out of the way. Now, let's jump in. We're going to use order of operations and we're going to evaluate some expressions here. And I'm not going to start out easy. We're just going to jump on in. We're not even going to start off with me giving you all the numbers. We're going to jump right in and say evaluate the expression if. What do you know is about to come next in a math problem when it says if? What are you about to do? You're about to do some plugging in, aren't you? Also known as substitution, right? Also known as substitution. Evaluate the expressions if m equals 12 and q equals negative 1. All right, number one, first expression, m plus parentheses 3 minus q, close the parentheses, squared. First step, every time. Before that, substitute. Our first step is to substitute. Don't try to combine steps. Go ahead and substitute here. Replace your m with a 12. Everything else is going to stay the same. Well, careful here. Behind this 3, what do I need to be careful of? Yes, I've got to have 3 minus, and then I plug in my q, which is negative 1. Okay? Now, as we build into this, we will probably do things like write the 3, and then if we know it's minus negative, write that as a plus. We will probably do shortcuts like that. But for right now, we're being very, very precise. All right, here we go. First step. What do I simplify first? Add 12 and 3?
No.
Of course not. What do I do? Yes, the 12 drops down. The plus drops down. Write that with me, please. Let's just get into some good practices here. And inside the parentheses, I have 3 minus negative 1, which is 4. Do I still need the parentheses here at this stage?
Yes.
Probably so, because I still need to do what? Square it. You see that square right there? So I probably still need to leave that parentheses on the 4. In the case of a positive number, you could do without it, but especially if that were a negative number inside the parentheses, you definitely still need it there until you square it. Got it? Can you finish for me? I think you got it from here. Finished out. Answer? Everybody. 28, fantastic. Not anything equals 28, and we don't go out to the side and add an equals here. We just simplify, 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 simplify. Do you know why I really, really insist that you go down instead of sideways? Because pretty soon we're going to have one of these on the left side of an equation and an equal sign, and one of these on the right side of the equation. And you can't move to the right to simplify, can you? Your only choice is to come down and simplify the left side and simplify the right side until you can solve. Not if that makes sense. Great. You can take your computer off your desk. I know you're kind of crowded. I'm sorry I didn't say that sooner. Feel free to ask me things like that if I don't think about it and you're all jammed up. Do I still need my book out? Do I still need this? It's okay to ask. All right, slightly more complicated. Let's try one that has a division element to it, a quotient here. 5m minus 6 over 2 times parentheses q minus 2. First step, replace. Is it okay to go ahead and do one step on the numerator and a step on the denominator all in the same line? Sure, okay, absolutely. But you do want to take this, you want to simplify the numerator as completely as possible and the denominator as completely as possible before you try to do any dividing. For space's sake on these quotients, I'm okay if you move to the side a little bit at the end. Final answer? -9. It matters, doesn't it? The sign matters, especially when you're in the midst of another problem. All right, pretty simple stuff. Okay about that? All right. This one's going to be a little bit more complicated because the numbers are a little bit more complicated. It kind of jumps up a little here. The directions are going to change. Write with me, evaluate if h equals 4, comma, j equals -1, comma, and k equals 0.5. And I want you to evaluate h squared k plus h times h minus k. All right, go for it. H squared k plus h times h minus k. Yeah, get those calculators out. Unless you can do 16 times 0.5 in your head, which 0.5 is the same as 1/2, and 16 times 1/2 is 8. Or even if you could do 4 times 3.5 in your head, which is 3.5 times 2. 4 times 3.5. What's 3.5 times 2? 7. So multiply it times 2 again, and you get 14. Answer? Final answer?
22.
That's it. Okay, so even when it comes to, decimals or more complicated numbers, number one, you have your calculator, and number two, if you follow the order of operations, it should be pretty straightforward. All right, I'm going to keep pushing. Let's brainstorm for a second. This is a super useful skill, especially this evaluating, when it comes to formulas. How many 10th graders do I have in here? Raise your hand if you're a 10th grader. Well, what do you think your hardest class is going to be this year, 10th graders? Wait, don't answer. 11th graders, what's their hardest class going to be? Chemistry. Chemistry's a bear. It's tough. It's tough, okay? And formulas, formulas in chemistry, okay? And using the skill that you just did right there is huge, being able to plug the correct variable into the correct place. And then, this is where math kicks into your chemistry. Once you've plugged in the numbers into the right place, punch them into your calculator in the right order, or evaluating them in the right order, understand? Understanding the mathematical principles about squaring it, how to use parentheses and whatnot. So let's talk formulas for a second. Rattle off some formulas that you can think of. Anything that you remember from the past. Come on, impress me. What you got? Any formula at all. Nothing is off limits. I don't care how simple or complex it is. Tell me a formula. Kaylin's got one in mind. Go ahead. If it's wrong, I'll tweak it with you. What you thinking of? Be brave. Come on, say it. What were you thinking of? Okay, a squared plus b squared equals c squared. That's a great one. Do we remember what that's a formula for, anybody? Pythagorean theorem relating to triangles. Good. I'm just brainstorming here. It's not that you have to copy down every one of these. I just kind of want us to think together. Tell me a formula. That was great. Thank you, Kaylin, for breaking the ice. What is that a formula for? For finding the slope. Yes, for easily finding the slope. Give me another formula. It can be mathy. It doesn't have to be. Whatever. It gives you what? Area of a square. Yeah, or a rectangle. Good. Area equals length times width. Come on, you know more than that. Don't remember any of your pi day formulas?
R squared, pi.
The area of a circle is pi r squared. No, pi r round. Yes. Okay. That's it. That's all we're going to come up with. What about for finding slope, like y2 minus y1 over x2 minus x1, or for a triangle, base times height divided by 2, or distance equals rate times time, or can't think of any others, huh? That's it. All right, well, let me throw one at you. Do you know this formula for volume of a cone? Volume of a cone. Anybody know that one?
Pi r squared times the height.
Yes, that's part of it. That would give you the volume of a cylinder, like a soup can. If it's a cone that comes to a point,
Divided by 2.
3. It's 1/3 of pi times radius squared times height. Very good. All right, so let me give you some statistics, some dimensions here. Write this down with me. If we have a cone with a height of 225 centimeters and a radius of 75 centimeters, can you find the volume? I'll say it again. With a height of 225 centimeters and a radius of 75 centimeters. Find the volume for me. You may use your calculator. Done? It's okay. Do as much by hand as you can. Go as far as you can. All right, guys, do you know how to do a fraction on your graphing calculator yet? If you don't, let's go ahead and learn a very important keystroke real quick. You see your math button over here on the left? Click math, then right, up, and enter. And you have a little flashy fraction there. Again, that was, I'm going to clear it out, math, right, up, enter. Math right up. That's your fraction button, okay, to take you to a fraction. Let me dim this just a little bit so that you can see better. All right. 1/3. You can also use 1 divided by 3. Make sure you arrow over so you're not under your fraction anymore. Now, you have 2 options for your answer. I need you to hear this because this is kind of important when it comes to anything relating with pi. You can, number 1, be exact, give an exact answer. Do you know what an exact answer looks like in anything dealing with circles? An exact answer, it's not a decimal. It's going to leave pi in the answer. If you want an exactly precise answer, Jesse, you have to leave pi in the answer. So in this case, you would multiply your 135 times parentheses 75 squared. Your little caret button here will raise something to the second power, or you can use your square button, times 225. And you'll get 421,875 pi. 21,875, write that down, pi, and that is your exact answer. It means nothing has been rounded or estimated. That is your exact answer. Now, what if you are actually measuring something out and you need an answer not left in terms of pi? You need to be able to measure it. Maybe you're measuring out liters, or maybe you're measuring out inches to fill it with something. Then you're going to need to multiply times pi. You can use that number times your pi button. So right here, I'm just going to press times, and it's going to say the answer, meaning it uses that previous answer. And I have a pi button right here. It is the second function on my caret key. Do you see that? Much better than using the approximation of 3.14, I'm going to push times pi and get my most precise, exact, estimated answer, okay? 1,325,359.4 centimeters cubed. All right, if your answer needs to come in centimeters and don't want to leave it in terms of pi, but if you're going on to calculate something further, you would leave it as pi. All right. And we have a couple more minutes. But I can sure tell you are getting tired of sitting.